x squared plus 3 over x squared plus x minus 2. And this is what a rational expression will look like. The first thing we need to deal with is domain. The important thing, the big thing to remember on domain is you want to look for values that make the denominator equal to 0. All right, so we're looking for domain only where the denominator equals 0, which means as long as we're dealing with domain, we don't really have to worry with anything in the numerator. We just have to worry with the denominator. So let's take a look at this guy. We've got him up there. And we want to find out what makes my denominator, which is x squared plus x minus 2 equal to 0. Should recognize this. You have to factor this guy. It's going to be x. Factors of 2 are going to be plus or minus 2, plus or minus 1. Because I've got a plus here, I know the 2 is going to have to be positive, and the 1 is going to have to be negative. Equals to 0. And now to solve this, I've got two different problems. I'm going to solve x plus 2 equals 0, x minus 1 equals 0, or x equals negative 2, and x equals 1. And these are the two values that are going to make my denominator 0. So what we know is that x cannot equal these two values. So the domain on this guy is going to look something like all real values of x such that x does not equal negative 2 and negative 1. There's your domain. Or x cannot equal negative 2 and x cannot equal negative 1. But all other real values will work. Okay? But x cannot equal those two numbers. So that's how you find the domain. I can also write this in set builder notation. So we know it's all real numbers, so I'm going to start off as negative infinity. And infinity is always parentheses because you can never include infinity. It's not a value, something that's uncountably large. Now I'm going to keep going until I hit to negative 2, but I'm not including that point either. Now I'm going to put a union, and then I'm going to allow all values between these two to be plus 1. Union with negative 2 to 1. And again, I can't include these 2 points. Okay, that excludes 1 and it excludes negative 2. Union with 1 that I don't include, and here we go all the way out to infinity. And that's set builder notation. Okay, add and subtract rational expressions. It's the same as you did for fractions. To add and subtract, you need a common denominator. And your calculator will not do this for you. Bummer. All right. Let's take a look at 1. And we're adding these, but you notice we do not have a common denominator. So your common denominator is basically multiply these two. So it's going to be x plus 5 times x minus 3. And that's our common denominator. That's what I'm going to want on bottom. Okay, well, on this one I've already got the x plus 5. But to get the x minus 3, I'm going to have to multiply the top and bottom by x minus 3. That's going to give me an x minus 3. Okay? Now I've already got this, but I need to get the x plus 5. And I've already got this down here, so it's going to be plus 2 times x plus 5. Okay? And now you go in, you distribute here. I've got x minus 3 plus 2x plus 10 over x plus 5, x minus 3. Combine my like terms, x plus 2x is 3x, negative 3 plus 10 plus 7 over x plus 5, x minus 3. And that's how you add and subtract these things. Okay, simplify. There's another skill you're going to have to learn how to do. And what we're trying to do is get rid of things on the top or bottom. This is the same as simplifying fractions, simplifying rational expressions. It's the same idea, except you're dealing with algebraic expressions and all of this stuff. So simplify. You want to make sure you factor top and bottom, numerator and denominator. And then eliminate things in common. Well, let's look at an example here. We want to simplify this rational expression. Okay, so let's take a look at this. You notice we're already factored up here. I've got this down here, so I'm going to rewrite this to make it a little more obvious what I'm doing. And now I'm going to come in, I'm going to break each one of these apart. So I'm going to have 3 over 6 times x plus 2 over x minus 1. Alright, so I've taken this down here, taken this down here, and then that's going to be times x minus 1 over x minus 1. Notice these are the same, so they become 1. This thing simplifies to 1/2. So now I multiply through. Got 1 times x plus 2 over 2 times x minus 1. And that is your simplified expression. Okay, multiplying and dividing. Let's talk about multiplying first. So your first thing, you're going to want to factor and simplify. The reason you want to do this is at all possible. You could simplify, you're getting rid of stuff that you don't have to mess with. If you don't factor and you don't simplify, then you're going to end up with these huge, long, horrible-looking expressions, and you're going to whine and cry and complain to me, and I'm going to have no sympathy for you. So factor, simplify, and then multiply across like fractions. Okay? So let's take a look at an example here. 4x over x squared minus 4. I want to multiply that by this rational expression. Okay, factor. That one already is. That's good. That one already is. That's good. That one already is, which is good. This one does not. You should recognize this as a difference of squares. And this is one of these things you're going to need to know how to factor. This becomes x minus 2, x plus 2, times x plus 2 over 16x. Now you notice I've got two terms in common, numerator and denominator. These will divide out to 1. Okay? So now what I do then is I just multiply across. So I've got 4x times 1, which gives me 4x, over. This is gone now, so I'm going to have x minus 2 times 16x. Okay, now we can simplify this guy a little bit more. And really, if I had come back in, and let's back this up a little bit, we actually have some common factors here. Okay, so I'm going to come back in and let's rewrite this. I'm going to have 4 over 16, which are these guys. Then I'm going to have x over, and you notice I've got an x down here, x. Okay, when you take a look at this, you'll see why it makes this a whole lot easier if you already do this. Now I'm going to come back in and I'm going to have, I've got an x plus 2 on the top and bottom. Okay, those are going to cancel out, and then I'm left with just a 1 on top and my x minus 2. Okay, this reduces to 1/4. This goes to 1. This goes to 1. So now I multiply across. I've got a 1 up here, and all that's left is this other 1. So I'm going to have a 1 over 4 times. That's gone, that's gone, that's gone. X minus 2. And you can see how much easier this is when you take the time to factor it correctly. I have 1 over 4x minus 8. And that is your answer right there. Okay, division. The first thing you're going to do when you divide is you never divide by a fraction. You flip the second expression and then you multiply. Okay? And by flip the second. So for instance, let's take a look at this one. I'm not actually going to come back in and do it again. And I want to divide that by 16x over, okay, I'm dividing. So what I'm going to do is flip that one. I'm going to multiply now. And if you take a look, this is the same problem I have just worked before. So you can go back in and take a look at it. Okay, Two other things then, and we're done with this section. First is simplifying compound fractions. And the first thing you're going to do when you look at these is freak out and say, there's no way I'm ever going to be able to do that. But let's take a look at one of these. X over y minus y over x. All of that is over 1 over x squared minus 1 over y squared. And this looks really, really nasty, but it's not that bad if you take it into small steps. So the first thing you're going to do is find common denominators for top and bottom, the big numerator and denominator. So I always start out on the very top. Let's do this one. And I'm not even going to sweat this one for now. I'm just going to do my numerator. I'm going to ignore my denominator. Okay, my common denominator here is going to be x times y. So when I do that and I pull this down, I'm going to have something over xy. To get this one, I've already got the y, I need to multiply by x. So I'm going to end up with an x squared. Now I've got an x, I'm going to have to multiply by y over y to get it. Excuse me, it's a minus. All right, so there is my numerator. Now I'm going to come back in, and I'm going to worry with my denominator, but I'm not going to mess with my numerator at all right now. My common denominators, will multiply these together. So my common denominator on this one is going to be x squared, y squared, over. Okay, so to get a y squared here, I'm going to multiply by y squared on the top and bottom. I'm going to have y squared minus, and here I'm going to have to multiply by x squared. Okay, and so now I have my denominator. Okay, you may think we haven't helped ourselves. Let's put this back together and I'll show you what's going to happen. Okay, so we come back in now and we put these together. There's my numerator, it goes on top. And that is all over all right, what you have to remember is this means division. So let's rewrite this problem as x squared minus y squared over xy, which is this one. And then it's divided by the stuff that's in the bottom. It's going to be divided by y squared minus x squared over x squared, y squared. Okay, now if you remember I told you that when you divide, you flip the second one and multiply. So I'm going to pull this down, and I've got x squared minus y squared over xy times, and I flip this one, x squared, y squared over y squared minus x squared. Okay, so now we've got this. Now let's rewrite this multiplication problem. This is, again, rational multiplication. So took this horrible thing, we've got it back to something we've dealt with before. So what I'm going to do is, I've got an x squared up here, And I've got an x down here. All right, that's good shape. Times, and I've got a y squared up here and a y down here. And then that's going to be multiplied by x squared minus y squared over y squared minus x squared. Okay, so this is an x times x and a y times y. So I know, so I've automatically come along, I've eliminated some stuff. I've got an x times a y on top. Now if you'll notice, the only difference between these two is that on one of them, my top one, my x is positive, my y is negative. On the bottom one, my y is positive and my x is negative. So we can make these the same thing by multiplying one of them by a negative. So it doesn't matter, but let's do it on the top. So I'm going to multiply this by negative 1. And that's going to give me y squared minus x squared. All right? Because all I'm doing is changing my sign. So now the y is positive and the x is negative. And then that will be over y squared minus x squared. And you should see that these will cancel out. So I'm left with is a negative 1, so that will give me a negative x, y. So all that boiled down to an answer of a negative x, y. Now it's a lot of steps, but they're little steps, and it will get you what you need to do. Last thing is talk about rationalizing the denominator. You never leave radicals in the denominator. So if I have 4 over the square root of 3, I cannot leave this in the denominator. So what I do is I multiply the top and the bottom by the square root of 3. So this will give me 4 times the square root of 3 over square root of 3 times the square root of 3, which is square root of 3 squared, gives me 3. And you notice I no longer have anything in the denominator. A radical in the denominator. It's up in the numerator, which is where we want it. Now, a slightly more difficult one, but not that much, is when you got a plus and minus down here. Now, if you take a look at this thing, this looks kind of like FOIL on binomials, where I have x minus a, x plus a is equal to x squared minus a squared. All right? Where then this would be an x and that. And what I want to do is get rid of this radical. All right? And if I square it, which is what this shows me, then it's gone. Okay, but I've got the x minus a, okay? This is x, that's a. And what I want is the other end, so what I'm missing is the x plus a. Well, that's not a problem. I could come in and I've multiplied the top by that. So basically what all you're doing on this is you're changing the sign of the radical over. Okay, so we haven't changed the value, it's still over 1, times 1 over 2 minus square root of 3. So this is